This is a review for Unit 1, Sections 1.1 through 1.5. In Section 1.1, we cover distance between 2 points. So if we consider these 2 points, I'm just going to approximate -5, 8, 19, 53, not to scale. But if you don't want to use the distance formula, you can think about where these points would be in a coordinate plane and turn it into a triangle. For example, the difference between the x-coordinates is 19 plus 5, or 24. The difference between the y-coordinates is 53 minus 8, or 45. And if you thought about this like a triangle, that's a squared plus b squared is equal to c squared. So to find the direct answer, you can take the square root of 45 squared plus 24 squared. And that gives you 51. So in other words, you're saying that 24 squared plus 45 squared is equal to 51 squared, the Pythagorean theorem. If you prefer to use the actual distance formula, when you plug in, you will get these same results, 45 and 24. Another distance problem. This time we have a diagram, and we have the coordinates effectively, so we do the same thing. We figure out a triangle like this, and it looks like our x is growing by 38, and our y is growing by 24. So I can take the square root of 38 squared plus 24 squared. And this one doesn't really come out as evenly. This would be the square root of 20, which is going to be 44.944, and then it keeps going. If we have one where you have to round on the quiz, I'll tell you which place to round to. Let's say it was the 100th place. Then this would turn into 44.94 because you look to the right and you round. And of course our unit here is yards. To find the midpoint, we're going to add together the x-coordinates and take the average. We're going to add together the y-coordinates and take the average. 10 plus 2 is 12, divided by 2 is 6. Negative 11 plus a negative 13 brings us to negative 24. If I cut that in half, I get negative 12. So this is my midpoint. This next problem gives you the midpoint and one of the endpoints. So if you think about this visually, one endpoint is here. The midpoint is going to be down here. So if we think about how many we went over and how many we went down, we can follow that pattern. I went 2 to the right, and then I went down 6. So if I do the same thing, if I go 2 to the right and down 6 from my midpoint, I'm going to be at 5, negative 8. So I did plus 2 to my x in the same way that I did plus 2 to get to 3. And I do minus 6 to my y in the same way that I subtracted 6 the first time. It's like you're repeating. Here we're finding percent change. The first one was from 1996, which is here, and then they show to the highest point in the graph, which is here. So for percentage, we like to think of things as old and new, not necessarily with milk, but with percentage. So I'm going to say 2.75 here for 1996 because it's between where the halfway point would be and the top. And then I think this looks to be about the halfway point, so I'll call that 3.9. One thing you can do is you can take new minus old divided by old. Or in this case, 3.9 minus 2.75 divided by 2.75. What you will get is 0.4181 repeating. And if you multiply this by 100, you get 41.81%. And that tells you how much you have increased. The other method that some people like is to go directly new divided by old. And what you get there is 1.4181 repeating. And if you think about it as you start off with your 100% and then you add the 41.81%, that tells you how much you increase. Both of these methods will work. You are increasing by just under 42%. For our symmetry tests, we're going to use the following patterns. If there is symmetry with respect to the y-axis, we're going to take our original xy and we're going to make the x negative. If there is symmetry with respect to the x-axis, it's the y that is negative. With the origin, you make them both negative. Let's give it a try. In blue here is the symmetry with respect to y-axis. Because when I plug in negative x, all of my exponents are even, it doesn't actually change anything, because all of the negatives end up canceling out, and I get the original equation that I started with. Negative x to the 8th minus x to the 4th plus 2. So that is actually my answer, because after I apply this change, it's the same as the original. That means there's symmetry. Let's try the others to see if they work too. If I make my y negative, that is not going to be the same as y is equal to negative x to the 8th minus x to the 4th plus 2. It's just not going to work out. So there's no symmetry there. If I try making both, again, there's not going to be symmetry because I'll have negative y on the left side and I'll have positive y on the right side. The other part works out though, the whole x to the negative x to the 8th and minus x to the 4th, that part works out. But the problem with both of these is that you have a negative and then the original is positive. So there's only symmetry with respect to the y-axis. To find the x-intercept, we're going to plug in 0 for y. So that tells us that 0 is equal to the square root of 9x minus 8. If I square both sides, I get that 0 still is equal to 9x minus 8. If I add 8 to both sides, and then I divide by 9, I get that 8/9 is equal to x. That's my x-intercept. If I want to do the same thing and find the y-intercept, that tells me that x is equal to 0. I plug in a 0 for the other variable. So this means that y is equal to the square root of 9 times 0 minus 8. And this is going to be undefined, because you cannot take the square root of a negative number. So there is no y-intercept. It's never going to cross that axis. You could graph these and find out these answers pretty quickly, but let's keep going with the algebraic method. For an x-intercept, I'm going to plug in 0 for y. Here that tells me that 3 is equal to the absolute value of x plus 1. So that means I split it and there's two possible answers. It's this one or negative 3. So this is where you have a positive and a negative solution because absolute value is distance from 0. On this left side, we have 2 is equal to x. On this right side, we have negative 4 is equal to x. Two possible answers for your x-intercept. To find the y-intercept, you plug in 0 for x. So this would be y is equal to 0 plus 1 minus 3. And that's the same thing as 1 minus 3 or negative 2. There's your y-intercept. When you take the 0 plus 1, it always comes out positive, so it just stays as 1, and then you subtract 3. If you remember the formula of the circle, what we do is we take this plus 4 that is right here, and the center, the x-coordinate, is going to be negative 4, the opposite. And we take this negative 3 halves here, and the center is going to be the opposite, a positive 3 halves. And since 100 is equal to r squared, if we take the square root of both sides, we find that 10 is equal to the radius. A similar thing happens with this one. Minus 3 becomes plus 3. 5 becomes minus 5. Since the diameter is equal to 98, I cut that in half and say that the radius is 49. And I want this to be r squared. So what I actually plug in here is 49 squared, which is the same thing as 2,401. Graphing and labeling equations, I'll do this one in blue. I start at negative 3, which is my y-intercept. I go up 2 and over 3, put a dot, there's my line. This one in red, if y is equal to 4, then I am looking at a horizontal line where y is always 4. If x is equal to negative 3, I'm looking at a vertical line where x is always equal to negative 3. So I have to label these. This is y equals 4. This is y equals 2/3 x minus 3. And this one here, x is equal to negative 3. So from this, I have to figure out my slope, and then I have to plug things in and figure out my b value. So first thing I do is I use the slope formula. I take the second y-coordinate minus the first, all over the second x-coordinate minus the first. Now, depending on if you want to convert these to decimals, or if you want to keep it as fractions, your calculator is pretty good at fractions. but eventually you'll figure out that 3/7 is your slope. So I'm going to write that up here. M is equal to 3/7. We're going to use that. The next thing I'll do is I'll pick out a single point and I'll plug in what I know. So if we think of this formula, I'm going to plug in 1 for y, 3/7 for m, and 3/2 for x, and then I can solve for my b value. If I multiply 3/7 times 3/2, I get 9/14. If I take 1 minus 9/14, I get that b is equal to 5/14. The last step is to put it all together and write out 3/7 x plus 5/14. If it's parallel to this, I can solve. So let's say I do plus 4y and minus 8 from both sides. And I get 5x minus 8 is equal to 4y. And I divide everything by 4. So I have 5/4 x minus 2 is equal to y. And that tells me, since it's parallel, that m is equal to 5/4. From there, I can plug in -2 is equal to 5/4 times 3 plus b. I'm taking my coordinate right here and plugging it in. This tells me that -2 is equal to 15/4 plus b. And if I take -2 minus 15/4, I end up with -23/4 as my b value. I'm just sticking with fractions because that's what we started with. Now to finish this, I'm going to write it in y equals mx plus b. So y is equal to 5/4 x minus 23/4. The next one is perpendicular, so if I solve this by subtracting 2x from both sides, and I divide everything by 3, this is going to be my original slope. My opposite reciprocal slope will be a positive 3/2. When you have two lines that are perpendicular, their slopes are opposite reciprocals. So I'm going to use the slope 3/2. Now let's take that point -8, 3 and use it. And we're going to solve our b value. This gives me that 3 is equal to -12 plus b, or 15 is equal to b. If I put it all together, I have 3/2 x plus 15. To evaluate these different functions, I plug in 3 here for wherever there's an x. So this becomes 3 cubed minus 2 times 3 plus 1. This is 27 minus 6 plus 1, which just gives us 22. For this next one, g of x equals 0 means I plug in on the other side. So this is going to be 0 is equal to x squared plus 9x plus 20. And if I use the x method here, let's put 20 on top and 9 on bottom, and the answers are 5 times 4 and 5 plus 4. So my answer here is going to be x plus 5 times x plus 4, and therefore my solutions are going to be -5 or -4. If I plug those in, I get 0 for y. This last one has me plug in an x squared, so the square root of x squared minus 3. Well, this is just x minus 3. The square root of x squared means the radical and the square cancel out. If we're talking about domain for this function, the problem is the bottom. You can't divide by 0. So when is 2x plus 6 equal to 0? So that's 2x equals -6 or x equals -3. So the domain is everything except x equals -3. So we're going to write it like this. For this next one, the restriction is in the denominator, we can't have something that is 0 and we can't have negatives. So 0 or negatives would be wrong because you can't divide by 0 and then you can't take the square root of a negative. So the 0 part would be when t is equal to 7, and the negatives part would be when t is less than 7. So the solution here, the domain, is going to be whenever t is greater than 7. All other values would work for this function. This one does not pass the vertical line test, so we're going to say not a function. This one passes vertical line test. This one fails the vertical line test, not a function. This one passes the vertical line test. Are these functions yes or no? What we're looking for here is in the x column, do we have the same input? What we're looking for here is, do we have the same input with a different output? Here, all of our inputs are different, so we're going to call this a function. For this one, you'll see that the domain of 2 is mapped to two different numbers. That is not a function, that's a relation. Every single time you have a 2, you should get the exact same value for your y, or your range. Even though the 2's repeat here, do they give the exact same output every single time? Yes, so it's still a function. Even though we see lots of 5's here, that's like your y value. So this is still a function because multiple inputs can map to 5. We just can't have that scenario where the same input maps to different outputs. So there's all of our functions, and not functions. For 1.5, we're going to find the zeros of the function algebraically. So we can start off by using our x method, ac on top and b on bottom. So this is 6 times 5, or 30 goes on top, and the 31 goes on bottom. We're trying to find out two numbers that multiply to give us 30 and add to give us 31. And those two numbers are 30 and 1. 30 plus 1 is 31, 30 times 1 is 30. So if I write out my factors like this in factored form, I can then take this 5, and I'm going to divide by 5 on both of these. And if I get a whole number, great, I'm done. And if I don't, like if I get x plus 1 over 5, and this one on the right, because you have 1/5, we can just multiply both things by 5, and that turns into 5x plus 1. And those are actually your two factors. However, they only wanted to find the zeros, and the zeros are going to be at this very first step. What can you plug in here to make this 0? That's -6. And what can you plug in here to make this 0? That's -1/5. Those are the zeros. For a function like this, we only care about the top part, so we only worry about when 8x plus 3 is equal to 0, or 8x is -3, or x is -3/8. If you want to determine if a function is even or odd, there's a couple of different steps. The first thing you do is you're going to plug in -x. After you do that, and you simplify, if you get the same exact function as your original, meaning the function does not change, that's considered an even function. What that means is there's symmetry about the y-axis. Generally, we see this with even exponents. The second possibility is that your result is opposite the original. Every single term is exactly opposite. Whatever was positive is now negative, or vice versa. If that's true, then your function is odd and symmetric about the origin. Sometimes, some of our function will be opposite, for example, but not every term, so that one would be classified as neither. If it's not the exact same or the exact opposite, then it's neither. Let's look at these three examples. Here I plugged in a -x wherever there was an x. If I resolve the negative, it looks like this. And if I compare this to my original, the first two terms are opposite, but the last one is not. So this one is not actually odd. We would call it neither. It turns out there's symmetry, but it's not about the origin. It's about this point -7. Let's try it again here. -x to the 4th minus 20 times -x squared. So all of the negatives are canceled out because I have even exponents. And is this the same as my original function? Yes, they're the same. And that means it's an even function. The last one here is x cubed. If I plug in a -x and cube it, this gives me -x cubed. Is this the exact opposite of my original function? The answer is yes, odd, because it's the opposite of the original. So if you put this into y equals and press graph, or if you're using Desmos and you start plotting some of these points, you'll see that there's a value here, then it curves down as it goes out, and then it keeps going up. So there's three things we're interested in. Here there's a relative minimum, and on this curve there's a relative minimum, and here is a relative maximum. Those are the three that we're trying to label. The relative maximum is just 0, -2. It comes out nice and even. To find these relative minimums, if you're using your graphing calculator, you press second calc. That's the alternate feature of trace there. It brings up a menu. You see minimum as an option or maximum. In this case, we're looking at minimum. It'll ask you to choose your left and right bound. You can just pick a point slightly to the left and a point slightly to the right. The actual minimum has to be between these two. You can press enter, enter, because it asks you to form a guess, which you could skip if you wanted to. And my relative minimum on the left here is this coordinate, which means the actual minimum is negative 2.25, since we're looking at the y value. You do the same steps here on the right. We establish a left bound and a right bound, and we're trying to find the other relative minimum. And it turns out it's the exact opposite. And it looks like that. So the relative minimums for both of those are negative 2.25, and the relative maximum is a negative 2. To find the average rate of change of the function between these two coordinates, we plug them in separately. So x1 we can plug in. That's f of x1, and it turns out that one is going to be negative 0 squared plus 8 times 0 minus 4. And f of x2 is going to be negative 4 squared plus 8 times 4 minus 4. And when we get an answer here, that's kind of like our y value. So this one is going to be a negative 4, and this one's going to be 12. So now I have x1, y1, which is 0, negative 4, and I have x2, y2, which is 4, 12. If I want to find the slope, I can use the slope formula. 12 minus a negative 4, all over 4 minus 0. This is 16 over 4, which is just 4.